Electricity in the human body. Unveiling the shocking truth, electricity, often associated with power grids and technological devices, is a fundamental force that plays a surprising role within the human body. While we don't typically think of ourselves as electric beings, the truth is that electrical currents are essential for the functioning of our cells, nerves, and muscles. Let's explore the electrifying world within our bodies. At the core of our biological functions lies a complex network of electrical activity. This phenomenon begins at the cellular level, where specialized structures known as ions channels regulate the flow of charged particles such as sodium, potassium, and calcium in and out of cells. These ion channels are like tiny biological gates, controlling the movement of ions to generate electrical signals. One of the most well-known examples of electricity in the human body is the transmission of nerve impulses. Nerve cells, or neurons, communicate with each other and with muscles and organs by sending electrical signals. These signals, called action potentials, travel along the length of neurons at speeds of up to 120 meters per second, about 270 miles per hour, to convey information and commands. Muscle movement, from the blink of an eye to a powerful stride, is driven by electricity. When your brain sends a signal to a muscle to contract, it triggers a surge of electrical activity. This electrical signal prompts the release of calcium ions, which ultimately lead to muscle fibers contracting and generating movement. The heart, a muscular organ responsible for pumping blood throughout the body, relies on precise electrical impulses to maintain its rhythm. Specialized cells in the heart generate electrical signals that coordinate each heartbeat. Irregularities in these electrical patterns can lead to conditions like arrhythmias, emphasizing the critical role of electricity in cardiac health. Doctors use electrocardiograms, or ECGs, to monitor the electrical activity of the heart. By placing electrodes on the skin's surface, ECGs can record the heart's electrical impulses, helping diagnose heart conditions and assess overall cardiac health. In neuroscience, electroencephalograms are used to measure electrical activity in the brain. These recordings of brainwaves help researchers and medical professionals understand brain function, diagnose disorders like epilepsy, and monitor states of consciousness. Understanding the role of electricity in the human body has far-reaching implications. Medical advancements in fields like neurology, cardiology, and physiology have been made possible by our knowledge of the body's electrical systems. Additionally, innovations like pacemakers and deep brain stimulation devices directly use electrical stimulation to treat various medical conditions. The human body's reliance on electricity is both fascinating and essential to our existence. It underscores the intricate interplay of biology and physics, highlighting the remarkable ways in which our bodies have evolved to harness the power of electricity for life-sustaining functions.